Thank you guys for staying around after 5. Welcome to reInvent. I'm Natalie White. I'm an Enterprise Solutions Architect at AWS.
And my name is Mateo Rinaldo. I'm a Senior Developer Advocate with the AWS CloudFormation Service team.
All right, so this session is DevOps 402, automating cross-account CI/CD pipelines. So this is a topic that's really important to a lot of our customers, and it's a very complex topic. So since this is a 400 level session, we're not going to go through many of the basics. We kind of assume that you are probably a developer or in a developer role, and we are going to be going through some code. So what we're going to do today is I'm going to talk for a few minutes about where multi-account pipelines, where multi-account deployments fit into your DevOps transformation. Mateo's going to talk a little bit about some important considerations to think about when you're starting to embark on a multi-account deployment strategy. And then I'll do a demo of a solution that I built that automates a cross-account CI/CD pipeline. And then we'll talk a little bit about how you can use cross-account deployments outside of the application development space and into the management and governance space. So we'll go ahead and get started. So when you hear the words DevOps transformation, that sounds very nebulous, like what am I even talking about? It helps to think about it in a transformation path that's maybe a little bit more familiar and concrete. So I like to talk about the transformation of a butterfly. So you've got the egg, which hatches and grows into a caterpillar. The caterpillar grows and becomes a chrysalis. A metamorphosis happens, and it becomes a butterfly, right? So some people may say that, oh, the butterfly stage is the most beautiful or the best, but each of these stages is extremely important, and each stage has its own advantages and disadvantages, and the cycle always restarts. And this transformation path actually mirrors what we end up doing when we start building things in the cloud. So we usually start out by building things in the AWS console. Maybe we'll use the AWS CLI, but it's a great way to learn how services work, experiment, learn how they connect together. But very quickly, it becomes difficult to manage because you're doing everything manually. It's extremely error-prone. It's very time-consuming. So customers will move on and start to use infrastructure as code. So AWS has CloudFormation and the CDK. Which one customers choose kind of depends on personas. So if you're more in the infrastructure space, you're very used to hierarchical text files, so you might choose to just do CloudFormation. If you're a developer, you might prefer to use the CDK, or if you want to build your developer skills. And the CloudFormation templates and CDK projects make it really easy to quickly deploy lots of things into a single account, usually. And so when you start deploying lots of things into a single account, especially multiple workloads or even multiple stages of an application, development, UAT, production, when you want to limit who has access to what resources, the only real way to do that is to get really fancy with your IAM roles. And that becomes very complex and difficult to manage and becomes a security risk. So kind of the next stage in the transformation is being able to deploy to multiple accounts. So this is a best practice that AWS recommends, and Mateo will talk a little bit about why that is. But keep in mind that this process is always going to be restarting. So we're talking about transformation of people, transformation of your processes, and transformation of the tooling that you're using. And this cycle will continue, right? You're going to start using a new service, try it out in the console, make some automation around it, start deploying at scale in multiple accounts. So keep this transformation in mind and see where you're at in your business or your cloud migration strategy. And keep that in mind when we start talking about multi-account deployments. So Mateo is going to talk about some important considerations that you might have when you start doing this, and then we'll go into the demo.
Well, thank you, Natalie. Yes, DevOps is a mindset. DevOps is a journey that will never end. So we want to keep all of these things in mind as we go over this never-ending journey. So this is a 400 level session that is going to be gravitating around topics related to the software development lifecycle, or SDLC, apply to a cross-account strategy. But before we get into the SDLC specifics, why don't we take one step back and see why are we even entertaining a cross-account conversation in the very first place? So an AWS account provides you with the highest level in resource isolation. This means that you can elect, you can choose to have discrete AWS accounts for all of your applications, for all of your workloads, for all of your business units. And for each one of these AWS accounts, you can choose to have processes, people, or a combination of both, to administer, to manage the life cycle of resources that you put on a given account. Another consideration to make as you design your multi-account strategies, you start to explore this world, is that in the event of an account, an AWS account being suspended, or the security breach, when you adopt a multi-account strategy, you have the opportunity to lower the area of impact to your resources. Let's make yet another consideration. Should you have any use cases where you wish to impose limits to a given workload? When you have more than one AWS account where you store different workloads on each one of these accounts, you can impose these limits without affecting, so to speak, other workloads that you have deployed into other accounts. So something to keep in mind. What else? So what I was mentioning earlier is that the AWS account provides you with the highest level of resource isolation. This also means that unless I have provided another user in another AWS account with the ability to discover, with the ability to consume, with the ability to leverage resources that I have in my account, they cannot do that. They can do that. So for use cases where you wish to restrict the visibility of workloads, a multi-account strategy is something that helps you. So last but not least, another consideration to make, think of all of your use cases where you wish to isolate data types of data into separate locations. I'll give you an example. You have your application that you build, test, and then deploy into an account. Let's call it account A. And what you do is you ship all the logs into another account. Let's call it account B, where you centrally aggregate, analyze, and audit all of this log data. Another example is where you have other accounts that you use to store, to persist information on recovery information, such as backups. So now that we have looked into a number of key considerations that you should make as you adopt a multi-account strategy, let's dive deeper into how all of these things apply into a software development lifecycle aspect. So as part of best practices, if you have an application, you want to build, test it, and deploy it automatically. As a matter of fact, should automate everything. So with that, there are a few things to think about. For the automation of build, test, and deployment actions, I need infrastructure as code, configuration management, for example, pipeline-driven orchestration. So an orchestration mechanism that makes build, test, and deployment actions on my behalf. Let's call this the control plane. Control plane. The other thing is the actual application that you want to build. Let's call it the data plane. So as a first consideration that you want to make when it comes to SDLC across accounts is you want to keep control plane and data plane separate. So recall all the considerations that we made earlier. around resource isolation. Yes, you can leverage AWS identity and access management policies in the same account, but considerations that we made earlier suggest that it's probably the best idea it's probably best to actually separate all of these components into separate accounts and get this data isolation, let's call it like this, out of the box. So you want to have an AWS account where you deploy your control plane. Let's call it the tooling account. Then you want to have one or more pre-production environments, such as dev, QA, pre-prod, perf, each one into its own AWS account, something that you want to consider, right? And then eventually, another AWS account where you store information related to your production account. So where you deploy the production version of your application. Now, automation. I want to automate the creation of the data plane, of course, but also of the control plane, which is what actually is going to enable me to build, test, and deploy the application on my behalf. So you have, the first step is having to decide how the permissions to deploy across accounts need to happen. So you have typically a security team in your organization or a cloud center of excellence or CCOE that says, this is how permissions need to be configured. And then you have either the same team or another team that operates on behalf of the security team that is composed of developers that translates all of these requirements with code. So to have predictability, so to have modularity, so to have repeatability, so to have automation. And in this case, for example, you can choose to have the AWS CDK with the language of your choice, supported today by the CDK, to describe your control plane, for example. Or depending on your personas, you can choose to have to edit your own AWS CloudFormation templates. And the first thing that you want to do is you want to set up who can do what and describe it with code. So the first thing is IAM roles. You want to deploy IAM roles into the tooling account, into the pre-production and production accounts, so that, and you want to configure them so that you establish a trust relationship between target accounts, in this case, data plane accounts, pre-production and production account, trusting the account where you put your control plane information. So once you have set this up, it's time to start building our control plane, meaning pipeline orchestration. And also, you want to feed your pipeline with data. So we need a pipeline orchestrator. In this example, we're going to be using AWS Code Pipeline. And how do we feed the pipeline? With code. Where do we store code? It's first code repository. In this example, we're using AWS Code Commit. And typically, you have either the security team or another team or a lead developer or a team that is supposed to, or that you empower to administer the configuration of these pipelines that sets up the pipeline, the source code repository with the CDK or with CloudFormation, for example. When you have these initial pieces of your control plane set up, it's time to consume it. So you have your application, you have your team of application owners. And what they do is they start to develop the application locally on their machine. And of course, as part of best practices, they want to run testing depending on what they're building. It could be testing for their application. They're going to be writing unit tests with the unit test framework of their choice. For infrastructure as code, for example, and they can choose to leverage AWS CloudFormation Linter or CFN Lint that gives you the ability to test the configuration of your resources against the AWS CloudFormation resource type specification, or for example, AWS CloudFormation Guard, also open source like CFN Lint, that gives you the ability to test, to validate the policy as code configuration of any JSON or YAML configuration files, including CloudFormation templates, against rules that you, or in this case, for example, the security team, writes. So developers start to develop and test all the changes that they want to share with the pipeline and with customers locally. They push their contributions into the source code repository. And you want to orchestrate your pipeline so that you validate again what developers have done on their machines. So you want to set up a continuous integration facility. For example, you can choose to leverage AWS Code Build, where you run, following the example that I made earlier, CFL lint, CloudFormation guard checks, unit test, code coverage, anything that you need, contract tests. And whenever you're ready, whenever you have your package, your deliverable ready, you have configured your pipeline to assume a role into each one of the control plane accounts, like pre-production and production, and deploy it. In this example, we're going to be using, we'll see later on, an application, an API, an Hello World API that is going to be fronted by an Amazon API gateway endpoint, and that is going to be backed by an AWS Lambda function. Okay? So now I'm going to give back the baton to Natalie, who's going to show us a demo of what we have just seen.
All right, thanks. Okay, so as you can see from this slide, we already built out something that's pretty complex, and there are a lot of dependencies happening. So what I'm going to do is I'm going to walk through some code that I wrote using the CloudFormation and the CDK to automatically deploy this architecture into an AWS account here in the next few minutes. So let me just switch my screen. Okay, so here we are in my tooling account. You can see here I don't have any CloudFormation stacks deployed at the moment, just the CDK Bootstrap resources that get created. And then you can see here I don't have any pipelines either, like everything's empty, right? We're going to deploy everything right here while we sit. And I'm going to kick off the script that I wrote, and then I'm going to walk through the code. By the time I finish walking through the code, we're going to have everything deployed. Okay, so what this solution consists of is a couple of CloudFormation templates that define the roles that are going to be deployed to my target or my deploy to accounts. We have a couple of scripts that have automated all of the calls that I need to make. Obviously, you can write this in any tooling that you want. It's just an example. And then I have CDK stacks that define the application that we're deploying, the pipeline that we're deploying, and the repository we're going to store all of our application code. So I'm going to close out this just so we can see more of the screen here. So we'll start with this automate deployment script. And at a high level, what this script is going to do is what Matteo just built out in the previous slide. It's going to verify that I have all of the environment variables that I need set, right? I'm not going to talk about setting up profiles for your environment. Like, this is a 400 level talk, so we're not going to get really deep into that. We're going to verify that those environment variables are set. We're going to deploy, using CloudFormation, those 2 IAM roles into each of the 2 accounts, the target accounts. Then we're going to deploy the repository stack. I kept my repository stack separate because maybe if I wanted to rebuild my pipeline or blow it away sometime, I don't need to get rid of my repository. I don't lose all of my code, so I'm keeping the stack separate for that reason. So I deploy my repository stack, and then I'm going to deploy my pipeline stack. So we're going to get into this. We're going to actually get into the code that the pipeline consists of. But you'll see here, after I deploy my pipeline, I've got a bunch of CloudFormation deploys again with those same IAM roles. And so if you're paying attention, that means that I'm doing something to them twice. And the reason that is because there's actually a circular dependency between the roles and the pipeline. So The pipeline needs the ARNs of the roles to be able to define the roles that the pipeline needs to be able to execute actions in the target accounts. So I need those ARNs to be created before the pipeline gets deployed. But those target accounts need access to the artifacts that the pipeline is creating in the tooling account. So that consists of the S3 artifact bucket. And if you're doing cross-account deployments, you have to use encrypted S3 bucket. You should be encrypting your S3 buckets anyway, but you have to do it for cross-account deployments, and you have to provide a KMS key for that. You don't want to use the default KMS key because you don't have access to change the policy on that default KMS key. You need to be able to change the policy because you need to be able to give the target accounts access to use that key to encrypt and decrypt objects that are in the artifact bucket. Hopefully this is making sense. Is everyone following? Okay, good. So the reason that I'm changing those roles twice is I'm deploying them without a policy first. I'm creating the pipeline, which now has the ARNs that it needs. Then I'm deploying the policies to the roles after the fact with the S3 bucket that I created and then the ARN to the KMS key. Okay, so then after all of that happens, we're ready to push to our repository, which will kick off the pipeline execution, which will deploy to my UAT and production accounts for the first time. Okay, so that's the automation script. Let's go through the roles that we have to create. So the first role that I have, I've called it a code pipeline cross-account role. So the reason we need two roles is we need to tell Code Pipeline what role to use when executing a CloudFormation deployment against another account. So that's what this role does. The way that I trigger whether the policy gets created or not is via a parameter. So I have a couple parameters here. You'll see I have the tooling account ID, which is one of the environment variables I had to set up in the first place. That allows me to have the reference back to the S3 bucket and the KMS key later. And then I have a key ARN. So I have a conditional statement on that key ARN. If I give it a key ARN, I'm ready to create that policy. If I don't have the key ARN yet, I'm not ready to deploy the policy. So I trigger the policy creation based on this condition here, whether I have the KMS key policy or KMS key ARN. Okay, so the role will always be deployed, but the policy itself is conditional based on whether I'm deploying the policy or not. The policy itself, we need access to be able to execute CloudFormation actions and also pass a role. The role that's being passed is the next role that we're going to talk about. And then I need access to be able to get to S3, all of the artifacts that are there. And I also need to point to that bucket that's going to be created. And then I need KMS actions as well. You can see here I'm going to give my account access to access my KMS key. Okay, so the second CloudFormation template is actually very similar in structure, but this role is used by CloudFormation to deploy our application resources into the account as a part of the pipeline. So again, I have the same parameters plus an additional one, right? Since I'm deploying my application, I want to say which stage of my application that I'm deploying to. So my stage is here as a parameter, either production or UAT. And then similarly, I have a condition based on whether the KMS key is there to determine whether my policy is going to be deployed. So this policy needs a few additional resources, obviously, because it's doing something different. We're going to pass that role in for the target account ID. And then we're going to allow IAM to be able to create new IAM resources, which is a part of creating the API gateway and the Lambda code. And of course, we have Lambda actions, API gateway, code deploy. We need all of that to be able to deploy our application, and then we have the same access back to S3 and the KMS key. And then we obviously have CloudFormation actions, which is how we're deploying the application. So you can see here that stage is being used to tell CloudFormation which stack we're deploying based on which account we're deploying to or which stage account we're deploying to. Okay, so both of these roles are what, a little over 100 lines of CloudFormation, not too bad, right? And I want to kind of step back for a second. Why did I use CloudFormation instead of the CDK to deploy these IAM roles? So when you're thinking about whether to use the CDK or CloudFormation, what you really want to think about is the trade-off between complexity, operational overhead, and how much you want to write, right? So for a role that's going to just be 100 or a few hundred lines of actions and definitions, it's not too bad. I can handle it with a text file. And this probably isn't going to change very often, right? The roles that, unless the application framework changes or the permissions change, it's probably not going to change very frequently. But if I did this via the CDK, I'd have to have another deployment like CI/CD pipeline to actually deploy it, because the CDK has to be, you have to build it, synth it, and deploy it, right? So this also kind of matches up with personas, right? Maybe my security team doesn't want to do the CDK, and they're going to they're going to use CloudFormation templates, and they're not going to use the CDK. So keep that in mind. Really, the goal behind using either CloudFormation or the CDK is to have our customers be able to choose what they're going to be most comfortable using. All right, so we're done with CloudFormation. I'm going to walk through the stacks that we're building. So the repository stack, super simple, very vanilla. It's just a code commit pipeline or code commit repository. The application, again, it doesn't actually matter what we're deploying here, so I kept it really simple. It's just a vanilla hello world application, but it does print out which environment we're in. So this is the Lambda code that would get put into the Lambda resource that gets defined in the application stack. So the application stack, again, nothing too groundbreaking here, but it's just an example of what you can deploy and the resources that would be needed for it. So the Lambda function is going to use my hello Lambda method, and then we're going to create an API gateway and create the Lambda versioning and things like that that we need. Again, nothing too groundbreaking here. We've just had a couple, less than 100 lines of CDK. The pipeline is where it gets a lot more interesting. So the pipeline is going to take in the UAT and the production application stacks. So you see those dependencies here, the interface to create my pipeline properties. And then we're going to start building out resources for our CI/CD pipeline. So we have here our repository. We just saw that. It's just a code commit repository. We have our UAT and our production roles. We start building out the role ARNs that we're going to need. And like I said before, these are the roles that the pipeline is dependent on to be able to link up the resources and provide that trusted access. So I'm building those out with the account ID environment parameters that I just showed you before. So I'm going to build out the ARNs for those roles. Remember, there's 2 roles per target account, so I'm building out those ARNs here. And then we're going to have access to the UAT and the production account principals as well to be able to give that access through the policies. So here we're going to create my KMS key. Remember, I told you we have to create our own KMS key. We don't want to use the default KMS key because we want to be able to grant extra permissions to that KMS key for the UAT and production roles. And then we're going to create our bucket, and of course, we're going to use our key as our encryption key. And we're going to give access to our bucket here. And then we start building out the pipeline with those prerequisite resources. So again, this is like code pipeline 101, so I'm not going to spend a lot of time showing this. But really, we're just going to access our repository. We're going to do a build, install all of our dependencies. We're going to synthesize the CDK stacks that I just went through. And the important thing here is that the artifacts that we're going to generate need the link to the encryption key that we created. So that tells code build that these artifacts that you're storing for me in my S3 artifact bucket, they need to be encrypted, and I want you to use this key. So don't forget to specify that, otherwise you're going to run into problems. So then we're going to also build out our Lambda code. Again, normal Lambda code, there's nothing fancy here, but again, we want to use that encryption key here in the artifact definition. So here's our pipeline. We're going to use that repository that we just defined. We're going to run those builds that we just defined as well for our CDK code and our application. And then the UAT deployment is defined this way. So this is really going along with all of the examples that you see in our GitHub repos. The main differences here are these roles at the end. So the role parameter is the code pipeline role that's going to be executing the deploy stage into the target accounts. And the deployment role is the role that's going to be passed through to execute CloudFormation on our behalf in the target account. Make sense? Oh, you're all good? Okay, good. The production deployment, very similar. Obviously, we're passing in the same role names for production. And then the last part is we're going to add access to the pipeline or to the target accounts at the end to be able to basically write back to the pipeline the status of those deployments. And then the key ARN is going to be an output here. So if you'll remember the path that we're taking, right? I need the key ARN to update the policies. So that's going to be an output of my CloudFormation template. And if I go back to the deployment script, where am I? You can see here, I'm writing the output of the CDK deploy to a temporary file and grabbing that output value to be able to feed in as that key ARN parameter here in my follow-on deployments. Does that make sense? We're all good? Okay, cool. All right, so that's it for our pipeline, right? And you can see down here my script has finished successfully, and I very helpfully have written out the command line things that I need to say to get the URLs. But first, let's go to the console and see what actually got built out. So let's refresh this. Code pipeline. So here you can see we have our repository stack and our pipeline stack. You don't see an application stack here because I'm in the tooling account, right? So we don't have those stacks in this account. We've deployed to the other account. That pipeline stack has all of the resources that I just talked about, right? We've got an S3 bucket. We've got the KMS key. We've got all the things that I just talked about that have been defined for me. And in my pipeline, we have my pipeline here. So let's take a look at that. You can see here the code commit push that we did has been retrieved. The builds were run for both the CDK stacks and the Lambda application. And then we've successfully deployed to both UAT and production. Now keep in mind that this is just a demo, so I didn't put a manual step in or anything, but you may want to add a manual step to your pipeline, and you can do that through the CDK really easily. So keep in mind that if you wanted to add more complex flows and everything, it's all in code. And my CDK stack for the pipeline is about a little over 200 lines of CDK, but the CloudFormation template that's generated by this is over 2,000 lines. So again, when you're considering, am I going to use CloudFormation or the CDK, consider how much you're going to be managing from an operational standpoint. Okay, so let's run these commands down here and get our URLs for our production and UAT. If I can get the right line here. Okay, so I'm going to go just update this and hello from the UAT environment, right? Our API gateway and our Lambda were successfully deployed. We used that environment parameter to say which environment we're in. And then here's my other URL, hello from the production environment. So in less than, 10, 15 minutes, I've deployed the solution that we just talked about in the PowerPoint slides, right? So I will publish this to GitHub so you guys can go play around with it after reInvent. But the idea here is you can take this framework and what we've gone through today to kind of help get you a kickstart, right? you can see the path of the different dependencies that are there, what's required, and what you can add, and start building on your own. All right, so we're going to go back to the PowerPoint slides for a second. Hang on just a second, let me grab this. Here we go. Did I do it? Yeah, okay, good. And Matteo's going to talk a little bit about how a framework like this can be used to deploy at scale in the management and governance space.
All right. Thank you, Natalie. So the takeaway we have seen is the isolation of the tooling account and the target accounts, control plane and data plane. Also, we have seen for the pipeline the discrete distinction between the continuous integration and the continuous deployment phase. So the source and build stage was the continuous integration, and then the deployment across all the other environments in this demo was the continuous deployment phase. So now we're going to go over another use case that is going to have a number of similarities with what we have just seen. So, and here it is. So even before you start thinking of having a software development lifecycle of an application or a workload, what you want to think about is at the inception of a new AWS account, when I create a new AWS account in my organization, what I want to make sure is that that AWS account is configured with a set of rules, guardrails, from a security, from a management and governance perspective. And I want to make sure that those accounts are configured the way I require, or the security team my organization requires. So no matter how large or small an organization is, what you want to do is you want to automate the creation, the realization of these resources that constitute your governance layer. And you want to do it in an automated fashion because machines are much better than us, human beings, in making these things also at a faster speed. So think about this. So you have a typical organization, as you can see here on the left, with the parent account and ancillary AWS accounts that you create for all of your business units, for all of your workloads, for all of your applications. And for each one of these accounts, you talk to your security team and say, what are the security management and governance requirements that we want to enforce as a line of defense into all of these accounts? Once we understand what these controls are, the other thing to do is, how do we deploy them at scale? Or even better, even before that, how do we test their effectiveness? So that's the problem statement, so to speak. Again, similarities. I'm sure you know where I'm going with this, right? So treating all these security controls as if they were an application, like the application that Natalie has just shown us. So automating security controls, automating the build, test, and deployment phases of your security controls, and treat them as if they were an application. So in this case, in this example, we're using the CDK, again, to start with the deployment of the control plane. Again, you can use CDK, for example, depending on if your personas are more conversant with software development, Parata, or you can use CloudFormation straight, CloudFormation templates if personas there are describing these resources with code are more coming from an operational background and they're more familiar with hierarchical, like JSON or YAML, declarative descriptions. So you want to start to build your control plane, and no need to rehash what we discussed earlier. So you see the similarities. You want to describe roles into target accounts. The control plane tooling that you can find on the left on this diagram. And depicted on the right side of this diagram, you find the control plane, the data plane, I apologize, which is constituted by all the AWS accounts to which you want to deploy your security controls. Once again, let's continue with the creation of the control plane. You need the pipeline orchestrator, very similar to what we have seen, a source code repository, where to store programmatically all your code, meaning the configurations that you have set up for your security controls. Source code repository, again, the single source of truth. If it's not committed to the repository, then it's not going to happen. So once you have your control plane set up, it's time to consume it. And you have the security team in an organization that is going to be creating all of these security controls, developing them into their machines, performing all the tests like we described earlier. Same considerations apply here. Once changes are ready, contributors push these changes into the source code repository, and the pipeline that you have configured will start to run build test phases that you have configured, depending on the data that you're submitting. Assuming that your security controls are going to be described with code, you want to perform linting for CloudFormation templates, for example, or validating the configuration of these security controls with a tool of your choice, for example, AWS CloudFormation Guard. And then whenever you're ready with these changes to be approved by a team, you will submit all these changes for approval, and eventually you're going to be deploying the security controls across accounts. As an example, depicted on the far right on this diagram, you'll find a number of security controls represented by services such as AWS Security Hub, then AWS Config, for example, AWS Config Rules, Amazon Guard Duty, and AWS Systems Manager features. So let's assume those are the security controls that we want to deploy into our target accounts. How does that work? How does that work? So you start with your pipeline orchestrator, like the one that you seen earlier, and you have an account that you choose to leverage in your organization as a sandbox account. This is where you will deploy security controls of which effectiveness you want to check, you want to validate, together with resources that you have configured only for testing purposes as not compliant. Then you push all the changes into the source code repository, meaning the description as code of your security controls. Then all of these changes are going to be tested again into a continuous integration phase, depicted here, implemented here in this example with AWS Code Build. And then using AWS Code Pipeline parlance, you're going to be using AWS CloudFormation as a provider, in this case, in this example, for a deploy action. You deploy with CloudFormation two things here. First off, the declarative description as code, all your security controls, and you deploy those into the account that you see here in the bottom of this diagram. And you also use one or more CloudFormation templates that describe resources that you on purpose, and again, only for testing purposes, you have described as non-compliant. For example, if you dictate that in your company, all the Amazon S3 buckets shall be configured with versioning enabled, and you have a security control that you leverage, and you want to test its effectiveness and say, detect that versioning is not enabled and do something to remediate about that. So for example, you would create an Amazon S3 bucket, you would describe an Amazon S3 bucket with versioning disabled, along with the security controls. And your goal is to get to the point where you start running tests against your security controls. You want to run tests leveraging your security controls against these resources that you on purpose as described as non-compliant, and provide evidence to an approval team that your security controls are working as you expect. And for that, you can leverage a compute layer to run tests and to collect the data and perhaps storing this data, these findings of non-compliant resources and their remediation into a place where an approval team can say, oh, I see your tests. I see that this resource was not compliant, this was remediated. So you want to get into a point where you collect through a compute layer all of this data and you provide evidence to a team, for example, the security team, that your security controls are working as expected. So the security team will see all these changes that you have provided, and if they agree and say, yes, this is what we need, you have configured security controls the way we expect, they can then choose to approve these changes. And typically for you to engineer that, as you recall earlier, Natalie was talking about adding a manual step into the pipeline. So for example, you could engineer your pipeline so that whenever you have deployed resources that are non-compliant and the security controls into a target account, the pipeline pauses because you have configured a manual approval. And then if the security team says, yes, we can go ahead, then they can choose to approve the changes. And once the changes are approved, the pipeline that you have configured will be able to deploy all of the security controls across all the accounts that you have in your organization. So that's basically the high-level strategy. Security controls treated as if they were an application. So what are takeaways from this mechanism? There are two major takeaways here. If you take a look at this mechanism, what you have here is effectively a mechanism that works at scale. If you describe your changes in an auditable, predictable way using code, you're already getting these benefits automatically, because this means that any team or any contributor in the organization that has right access to the source code repository that you see here, for example, they can say, oh, I am team XYZ in my company, and I want to unblock ourselves because we have additional requirements. So as opposed to going to the security team and say, security team, can you please implement the security controls for us? They can do that themselves. This team can make changes, propose changes in the source code repository. These changes will go through the process that we have seen earlier, and eventually the security team will just need to go through these changes and say, yes, we approve. No, we are rejecting them for this reason. Please start again. So this means that the first benefit is you have unlocked potential for your teams so that they can unblock themselves. The second one is the security team is gaining some time back, because as opposed to maintaining the life cycle of all of the security controls themselves, since you are empowering other people, other contributors, to do that through this mechanism that works at scale, now they have some time back and they can use it. Recall the Chrysalis life cycle, the DevOps mindset journey that never ends. Perhaps they can say, we want to find ways to write tests that we will trust 100%, so we can swap human-driven scrutiny with machine-driven scrutiny. And perhaps we don't even need to have a manual approval in the future. We can, if we trust our test that we have now time to build, we can create a manual, we can create an automated approval or disapproval. So with that being said, I'd like to give back the baton to Natalie for some final considerations. And there you go.
Thanks. Okay, so you can see here that we've talked about cross-account pipelines in an application space, kind of the complexity that's involved, but the fact that using infrastructure as code can make it faster and easier for your team to be able to operate at scale. And the way this fits into your DevOps transformation journey is changing your team's culture, right? So instead of gates, we now have guardrails around what teams can do, which helps them build faster and innovate faster, and helps unblock your team from being the bottleneck. So think about that when you're talking about cross-account pipelines, and we can't wait to hear what you guys are building with cross-account pipelines. Feel free to follow us on Twitter or LinkedIn. I will definitely post a link to the GitHub repo when I get it published publicly, and keep on building. We'd be happy to take questions after the session since we have maybe around 9 minutes left, but that's the end of the session. So thank you guys for coming.